Climate and weather. Together, they are among the most influential forces on Earth. One can influence where and how we choose to live. The other often determines what we do, where we go, and what we wear each day. Climate refers to the average weather conditions of a place over a long period of time. The Earth has 6 main climate zones. Some are mild and inviting, like the Mediterranean climate of southern Europe. Others are harsh, like the arid deserts of northern Africa and the frozen tundra of Greenland. Through history, climate has often played a part in where people have chosen to settle. In the ancient world, some of the first permanent human communities occurred in places with hospitable climates. But humans have long had an amazing capacity to cope with more severe and challenging climates. Today, with widespread use of refrigeration for foods and of air conditioning and heating for homes, humans can survive in all climates, including the frozen desert of Antarctica or the blazing heat of Death Valley, California, where temperatures can soar above 130 degrees. Weather, on the other hand, refers to the day-to-day conditions of the Earth's atmosphere at a particular place and time. Weather can be glorious or annoying. It can also be devastating. Severe weather can destroy homes and property, cripple transportation, ruin crops, and create havoc for people caught in its path. In the United States, weather causes, on average, more than $11.4 billion in damages each year. About 15% of that damage occurs in Florida alone, a state that sees more than its share of hurricanes, floods, and tornadoes.
This region includes the whole of the Indus Plain except the coastal areas. Most parts of the Indus Plain lie western end of the tropical monsoon at the zone. It has arid and extreme climate with hot summers, cool winters and summer monsoon rainfall. The amount of rainfall differs from north to south. The foothills of the northern mountains and Potwar Plateau are wetter than the Indus Plains and also receive rainfall from western depressions. Thunderstorms are also common in the north and northwest of the Indus Plain. The southern upper Indus Plain and the whole of the lower Indus Plain have much less rainfall and spells of very high temperature. The temperature is moderate. The difference between maximum and minimum temperature is less. There is inflow of sea breeze throughout the summer and the humidity is high.
A maritime influence is an influence in which areas near the ocean receive more precipitation. In summer the land heats up, while the ocean remains comparatively cool. In winter the land loses heat quickly and becomes cold while the ocean is much warmer and keeps its warmth for a long time.
The South Asian monsoon is a system of winds that reverse direction at roughly the same time every year. As they move up and down the Indian subcontinent, these winds carry fresh water to hundreds of millions of farmers. Consequently, the usually highly predictable monsoon rains are the lifeblood of agriculture throughout the Indian subcontinent. The monsoon has two phases. The first carries moisture from the Arabian Sea up through the Indian subcontinent. It begins in June and covers most of India with rain until September. In late September, these winds reach the Himalayas and make an abrupt about-face. From late October to December, the monsoon glides back down over the subcontinent on its way to the Indian Ocean. The monsoon rains are the main source of water for 55% of the country's arable land. This means the rains are crucial, not only for India's farmers, but its economy as a whole. Now, that's a good thing when the monsoon arrives on time and brings the right amount of rain. But when it's late or weak, it leads to drought. When it's too strong, it can trigger floods. The two-phase pattern of the winds defines Indian agriculture, so when the pattern shifts even slightly, it can have real implications for food production.
As this warm air moves away from the sea towards the mountains, something crucial will happen to it. Let's take a volume of this air. You can't see it, but it has water in it in the form of vapour. How much vapour depends on the air temperature. This mass of warm air at 30 degrees can hold around 15 grams of water vapour in every kilogram of air. When the temperature of the volume of air goes down beyond a certain point, the water vapour condenses into water droplets. The droplets form around specks of dust or around specks of salt picked up from the sea. We can then see the water as clouds. And when the droplets grow large enough, they fall as rain. This whole process happens as the warm air rises and cools against the windward side of the mountains. 2 or 3 times a week you can see it with your own eyes. This is temperate rainforest, one of the rarest vegetation types in the world today. In these conditions, there's always a huge difference between the rainfall on the windward side of a mountain range and on the other side, the leeward. It happens worldwide where mountains stand in the way of the westerly winds in the temperate latitudes.
Locals, one of these is just as important as sunblock. In fact, they have a saying, the hotter it is, then the harder it will rain.
That's because the weather patterns here are dominated by convectional rain. It's another way in which air is lifted and cooled. When the ground gets intensely heated by the sun, the warm air rises. As it does so, it cools and the water vapour condenses. Clouds are formed, eventually leading to rain.
Converging trade winds meet. The warm air, heavily laden with water vapour, is forced to rise. In the cooling air, water vapour condenses into droplets. This change of state from water vapour to liquid releases latent heat, which further warms the atmosphere and allows it to become more and more buoyant. The air rises even more rapidly and produces more and more violent thunderclouds.
But that's only the beginning. Trade winds drawn in at the Earth's surface arrive on a curved path due to the Earth's rotation. Here we see the first recognisable pattern of a spinning tropical storm. As the storm grows larger, more moist warm air is drawn in at the surface. More water vapour condenses into cloud droplets and more latent heat is released. This is how energy is driven into the storm and the speed of rotation increases. This system is now a tropical storm, and when the surface wind reaches sustained speeds of over 74 miles an hour, the storm is officially a Category 1 hurricane.
We've all seen pictures of hurricanes hitting land, but what's happening inside the storm?
Rising currents of warm, moist air form thunderclouds. As the air cools, it becomes more dense and falls again, and we get this alternating pattern of storm clouds with clear slots in between. This gives us the appearance of spiralling rain bands, which we see on satellite pictures looking down on hurricanes from above.
Hurricanes are measured on a scale from 1 to 5 depending on the wind strength. As a hurricane grows in intensity, it develops a very distinctive structure with what looks like a hole in the middle of a swirling mass of clouds. This clear zone in the centre of the storm is called the eye, and around it is the eye wall. The eye wall is the most destructive part of the hurricane, containing the most severe thunderstorms and the very strongest winds. In a Category 5 hurricane, winds in the eye wall can exceed 155 miles an hour. Yet in the eye itself, the wind drops right away to give a short-lived, eerie calm.
As well as causing massive damage simply because of their destructive strength, hurricane-force winds can have an even more devastating side effect.
Western disturbance is the low-pressure system that originates over the Mediterranean Sea and moves eastwards. This causes rainfall in Iran, Pakistan, and India, and snowfall in India.
Sometimes you have to see to believe. National Geographic in high definition. The real world redefined.